Alright, the square root of 8 divided by 2 times the square root of 5 plus the square root of 6. So this guy's bad news because you've got a radical on the bottom and you got a radical on the bottom. You've got two different terms. So the only way that you are going to turn this bottom mess into a rational number is you've got to times it by 1. And your 1's going to be pretty clever. Your 1 is going to be the conjugate of this. So 2 square root of 5 plus square root of 6, the conjugate is 2 square root of 5 minus square root of 6. And you got to times the bottom and the top by that. So now it's just a lot of distributive property. You got to times this to this and this to this. So if you do square root of 8 times 2 square root of 5, in front of 8 the coefficient is 1. So you times your coefficients together, 1 times 2, it's going to give you 2. Square root of 8 times square root of 5 is square root of 40. And then if I times that to the square root of 6, I'm going to get a square root of 48. Okay, on the bottom. These need to be cleaned up though. Before you distribute, if you would have cleaned up that 8, it would have made the work maybe a little bit easier. So anyway, these guys got to be cleaned up. Keep that in mind. 2 square roots of 5 times 2 square roots of 5 is going to be coefficients. 2 times 2 is 4. Square root of 5 times square root of 5 is square root of 25. And then 2 square roots of 5 times a minus square root of 6 is going to be a minus 2 square roots of 30. And then a square root of 6 times 2 square roots of 5 is going to be a plus 2 square roots of 30. And a square root of 6 times a minus square root of 6 is going to be a minus square root of 36. So it looks kind of messy, but it's pretty nice. Those are opposites, negative 2 and a positive 2, so that's 0. Square root of 25 is 5, so that's really 4 times 5. So my bottom, I've got 20 and then minus 6. So my bottom, I've got 14. Okay, then your top, you just got to clean up these. So 40, let's play with 40. What's inside 40? 4, 10, 2, 5, 4 is 2 and 2. So if that is 40, you're going to take a 2 out. And you're going to leave the 2 and the 5 in. And if you take a 2 out, there is already a 2 out there. So you times those together. So it's going to be 2 times the 2 you bring out. So that's going to be 4. And on the inside, you just have a 2 and a 5. So that is 10. Okay, now it's kind of messy, so I'm going to do this one over here. A minus 1 square root of 48. 48 is 8 and 6. 8 is 2 and 2 and 2. Done, done, done. 6 is 2 and 3. Done, done. So 48 is 2, 2, 2, 2, 3. So I'm going to take, there's 2 squares in there. There's a square, there's a square. So you're going to take a 2 out, you're going to take a 2 out. And you times them. 2 times 2. So you're going to swap out a minus square root of 48 for a minus 4 square roots of 3. And now, because this and this and this all have a common factor, you're dividing both of these terms by 14. So simplify this fraction. You need to reduce it. 4 and 4 and 14. 4 fourteenths is 2 sevenths. So we got this. 2 square root of 10 minus 2 square root of 3 over 7. Okay, the next one, if you have this squared, it is just going to be this times itself. So it's going to be 3x square root of 8x cubed times 3x square root of 8x cubed. So you can have the coefficients 3x times 3x, that's going to be 9x squared. And now this guy, square root of 8x cubed times square root of 8x cubed is square root of 8x cubed squared. It's that times itself, and this square and the square root, they're going to undo each other, so it is just going to be 8x cubed. And 9x squared times 8x cubed is going to be 72x to the 5th. This one you got to do a lot of distributing. You need to times this to this, which will give you a square root of 22. You need to times this to this, which we got a plus, will give you square root of 11 times 33. 33 has an 11 in it. It's 11 times 3. So you are going to take that square out right there. Take that square out, and that's going to be 11 square roots of 3. Okay, so I'm going to put these guys in the bank. I got a square root of 22, and I've got 11 square roots of 3. Now let's do this times this. A negative square root of 6 times 2. 6 has a 2 in it, 2 and 3. So that's a negative square root of 2 times 2 times 3. That's a square. Take that 2 out, so it's going to be negative 2 square roots of 3. And then I've got to times this piece to this piece. A negative square root of 6 times 33. I know they both got 3's in them. 6 is 3 times 2. And 33 is 3 times 11. So I got a 3, a 3, a 2, and an 11. So take the 3's out, and it is going to be a negative 3. And you got a 2 and an 11 in. Times those together, 22. Okay. Now, these and these are like terms. So if I've got 11 square roots of 3 minus 2 square roots of 3, my total is 9 square roots of 3. And I got 1 square root of 22 minus 3 square roots of 22. That is a minus 2 square roots of 22. And that's as far as you can go. 2 terms. Square roots of 3 and square roots of 22. Last one. Oh, I'm not sure what I did there. Last one. 6,300. Okay, that's got a lot of squares in it. I'm going to do 63 times 100. And that is a 10 and a 10. That's a perfect square. Square root of 100 is 10. 63 is 9 times 7. And 7's done. 9 is a square. 3 times 3. So I'm taking a 3 out, and I'm taking a 10 out. So I've got a 4, a 3, a 10. Brinley, sit down. Now, let's do the x's. You've got 27 of them. 27 x's. How many squares are in there? You're going to have 13 squares. Okay, 13 squares is 26, and you're going to have 1 left over. So this square root is going to undo this square, so you have 13 squares coming out, and 1 that stays in. The y's, if I've got 65, 65 is the same thing as 32. 32 squares is 64, and 1 left over. So if you've got 32 squares, this square root's going to undo the square, so you got 32 coming out, and 1 left in. And the z's, 6,300, 6,300. If you cut that in half, all of the z's will come out. That is 3,150. So that's your answer. 4 times 3 times 10. 4 times 3 is 12. 12 times 10. Swap that out for a 120. And there you go. Okay, acceleration. 2 more. We're almost done. Yeah, I'll get you. Okay, alright, acceleration. So you are on some planet. And let's see, right there. So maybe a moon or something in space. The acceleration is slow. Oh yeah. Acceleration is 10 feet per second every second. So if you drop an object near the surface of the planet, its initial speed will be 0 when the time is 0, and then its instantaneous speed, so the speed at that exact moment, after 1 second it will speed up from 0 to 10. And then after 2 seconds it will be going 20 feet per second. So what will its instantaneous speed be at 6 seconds? It will be 6 times 10. It will be 60 feet per second. Okay, now the distance traveled between the interval of 6 and 7. Distance equals rate times time. So let's do seconds and let's do speed. Okay, 6 seconds, it is going 60 feet per second, and at 7 seconds it is going 70 feet per second. So now the interval between 6 and 7 seconds, the time lapse between that is only 1. So I'm going to plug 1 in for my time, and the speed was changing during that interval. The speed went from 60 all the way up to 70. So if your speed is changing at a constant rate, we're going to use the average speed. So right in the middle of 60 and 70 is 65. So distance equals speed times time. 65 times 1. So between the 6th and 7th second, that object traveled 65 feet. Okay, now what will the total distance be? So that is the total, that is the interval of 0 and 7. So I'm going to go clear back to 0. 0, the speed is 0, and the average of 0 and 7 is 35. So for my speed, I'm going to use 35, and for my time, I am going to use 7. So 35 times 7 is a total of 245 feet. Okay, question D, when is this going to hit the surface? So at the 7th second, we have only traveled 245, and we need to travel 1500, so I think it's going to take a while. So let's tackle this one right now. Maybe 7 seconds didn't go much. Let's jump clear to 20 seconds. Let's see where it's at 20 seconds. Okay, at 20 seconds. 20 seconds, its speed will be 200. So if I want the total distance from 0 to 20, I'm going to go from 0 to 200. That is an average speed of 100. So distance equals rate times time. I'm going to use 100 times 20, and that is 2,000. Okay, so I know that it is less than 20. So you can kind of pick around, bounce back and forth, and narrow it down. If you know the function, it's going to make it much easier. So let's do the function. Distance equals rate times time. Okay, so distance equals, your rate is changing, so the rate depends totally on the time. So whatever your time is in seconds, so you take how many seconds, so we just took 20, and we got 200. So you take the seconds and you times it by 10. Now that's its instantaneous speed. And you want the instantaneous speed and go all the way back to 0. So add it to the speed of 0 and then find the average of those two. So that will be your speed, and your time then we took that 200, and we took that 200 and 0 and found the average is 100, and then we did the 100 times 20 because it was in the air for 20 seconds. So now you got to times it by how long it's in the air, so whatever your seconds is. So this is it right here, which is y equals 10s divided by 2 times s, which is 5s squared. 5 times the second squared. That will give you the distance. And then f, we can do f. And then we'll go back and do d. Alright, so f, erase some stuff. If you want the position and you know the distance, so if this distance was 2 grand, then if I want its position, I take what I dropped it from. I dropped it from 1500 and I minus 2 grand, and that object is 500 feet below the surface. So I just take position. To get position, I do the total distance minus the distance traveled. So it is going to be position equals my total distance from when I dropped it, is I guess what I mean, the height at which you drop it, 1500 minus 5s squared. That formula will give you the rock's position at any given second. Okay, so if this will give you the position at any second, type that in your calculator and graph it, and then look at the list. It's 1500 minus 5x squared. Type that in, look at the table, and you can see when it's going to hit 0, and it should hit 0 right in between. And this is good enough. For D, just tell me between. Between should be 17 and 18 seconds. So if you need help typing this in and looking in the table on the calculator, make sure you know how to do that before the test. And this last slide, you're on your own. This is a good to the fourth thinking skill right here. Thinking problem. Do it.